Welcome to this explainer. Today, we are completely unpacking the multi-agent AI architecture behind Builder OS. We're getting an exclusive look right under the hood, taking what is basically an insider's technical briefing and translating it into a clear, actionable blueprint just for you. Seriously, if you've ever found yourself wondering how to level up from a single, basic chatbot to a massive, interconnected ecosystem of AI agents working together, well, you're in exactly the right place.
Okay, so here's our blueprint for today. First, the magic interface. Second, the engine room. Third, the secret sauce. Fourth, the honest gap list. And finally, number 5, the deployment roadmap. Let's get right into it. Kicking things off with part 1, the magic interface, taking a look inside the MD Command Center. Just imagine, right? A CEO or managing director simply asking, which projects are delayed, in plain, everyday English. There are no complex SQL queries to write, no hunting and pecking through 15 different dashboard tabs. You literally just ask a question and boom, you get an instant, completely accurate, and business-readable insight right back. It's like texting a hyper-competent assistant. It is absolutely fascinating to see how the orchestrator pulls this off behind the scenes. So, the moment that question comes in, the system fires off 3 specific steps. First, it instantly classifies the real intent of your question. Second, it generates a perfectly safe SQL query. And third, it executes that query and interprets the raw data, flipping it back into an actionable business insight. Oh, and it actually remembers the last 4 turns of your conversation. So your follow-up questions, they feel like a totally natural, flowing conversation, not some rigid search engine prompt. Now let's talk about the safety foundation here because this is absolutely crucial. The AI intent classifier actually drops requests into 13 distinct buckets, things like lead analysis, vendor performance, or finance. If it finds a match, it routes it super fast. If it doesn't, no problem, it just generates custom SQL on the fly using a natural language fallback. But look at that last point, strict, read-only guardrails. There's literally no way the AI can accidentally wipe your data. Any query trying to use commands like drop, delete, or update gets completely blocked before it even looks at the database. So the AI can read your data, it can give you brilliant advice, but it absolutely cannot silently mess up or destroy your company records. Moving right along to section 2, the engine room, where we are breaking down the 8 specialized agents. So, this whole system runs on LangGraph, which is an orchestration framework built specifically for complex, multi-step workflows. We are talking about exactly 8 distinct agents. You've got a lead intelligence agent, sales conversion, project execution, procurement, finance, compliance, quality, and even a customer experience agent. Instead of trying to force one giant jack-of-all-trades AI to do everything poorly, you have this elite team of 8 specialists, each totally laser-focused on their own specific domain. And here's the brilliant part. Every single one of those 8 agents operates using the exact same standardized 4-step pipeline. They fetch relevant read-only data, they run their AI analysis based on their specific logic, they save their decisions, and finally, they generate an alert in plain, simple language. But honestly, pay super close attention to step 3, save decisions. Every single time an agent scores a lead or, say, flags a risky vendor, it saves its reasoning directly into an agent decision memory store. That means you get a fully auditable trail. If you ever sit there and wonder, hey, why did the AI flag this specific lead as a high priority? The receipts are right there in the database for you to check. All right, on to section 3, the secret sauce. Let's look at the cross-agent memory bus. So how exactly do we turn a bunch of isolated bots into a fully coordinated hive mind? Well, the answer is this cross-agent memory bus. Think of it like a shared context store, right inside the database. When one agent discovers something important, it basically shouts it out by publishing a specific signal here. Meanwhile, all the other agents are constantly listening to this bus for signals that might impact their own jobs. It's a real game changer because it allows them to coordinate entirely autonomously, no humans needed, and it actually maintains that context for up to 12 hours. When you look at this mapping, this is really the major aha moment for the entire architecture. Let's say the project agent suddenly detects a critical structural delay on a building site. It immediately publishes that delayed project's name straight to the shared bus. Instantly, the lead agent picks up that signal and automatically deprioritizes sales efforts for that specific building. I mean, why push your team to sell units you know for sure you can't deliver on time, right? But wait, at the exact same time, the customer experience agent sees that same delay signal and proactively drafts a sensitive, honest apology message to send to existing buyers over WhatsApp. Just think about that. No human project manager had to run around scheduling an emergency meeting between sales, site ops, and customer service to make this happen. The cross-agent memory bus just handles the whole shebang dynamically.
Now for Section 4, the honest gap list, where we compare the prototype to a real production SaaS.
Okay, time for a bit of a reality check. Because for all that mind-blowing high-tech intelligence, the scrappy reality right now is that the data layer is just sitting on a single developer's laptop using SQLite. It's totally reliant on fake seed data, dummy project names, fake vendors, that sort of thing. It's a proof of concept. To actually go live, all of this needs to be migrated over to a highly scalable, robust Postgres database living out in the cloud.
And looking at security, well, the current prototype basically has wide-open endpoints and absolutely zero authentication. Obviously, a real enterprise deployment absolutely requires multi-tenant data isolation. You literally cannot safely onboard more than one builder without strictly enforcing row-level scoping by organization. Plus, you need solid role-based access control to dictate exactly what a builder admin is allowed to see versus, say, a vendor or a channel partner.
As for the actual AI brain itself, the current setup is running a local Llama LLM, which is great because it's free and entirely private. But let's be honest, it's pretty slow and definitely not scalable for a production environment. The end goal here is a lightning-fast hosted LLM like Grok. And thankfully, the developers actually anticipated this exact switch. Upgrading from that local test model to a blazing fast, production-ready LLM is literally just a one-line configuration change that they designed in from the very beginning.
And finally, Section 5, the deployment roadmap, where we talk about building the real foundation.
To actually get this thing to production, it requires executing a very logical 4-phase roadmap. It's pretty straightforward. Phase 1 is all about making it real. Phase 2 is making it safe. Phase 3 is making it usable, and Phase 4, that's where we finally make it fully enterprise-ready.
These steps really boil down to vital conventional software engineering. First up, flipping the switch on Grok and Postgres. Once that's done, you lock down the security by adding API authentication and that tenant isolation we just talked about. With safety handled, Phase 3 is connecting a slick front-end UI and live WhatsApp business APIs so those notifications actually go out. And then the final boss, Phase 4, is full cloud containerization and wiring up those heavy-duty third-party integrations, stuff like SAP, Tally, or banking portals, so your AI agents actually have real-time operational data to chew on. I really want to highlight this quote straight from the leadership briefing's bottom line, because honestly, it sets the perfect perspective for everything we've talked about today. It says, the hard intellectual work is largely done. What remains is conventional software engineering. Think about what that means. The massive, scary R&D risks, figuring out complex agent logic, the prompt reasoning, getting that cross-agent memory bus to actually work flawlessly. All of that is already solved and validated. What's left on the table is highly predictable, totally estimable nuts and bolts software build-out work.
As we wrap up this explainer, I want to leave you with one final thought to chew on. You have just seen the exact step-by-step blueprint for a multi-agent AI layer. We went from that magical user interface all the way down to the rigorous engineering required to actually make it real. The really hard intellectual R&D, it's solved. So when you look at your own technology stack, how are you going to bridge that gap and build your own autonomous, enterprise-ready AI foundation?